Welcome to the ARM School programme. This video is taken from our teacher training programme on edX.org called Teaching with Physical Computing. Whether you're new to teaching computing or a specialist, this programme will set you up on a path to becoming an expert in delivering technology-enabled project-based learning in the classroom.
This module introduces a number of learning theories that have implications for the teaching approaches and strategies associated with physical computing, project-based learning, PBL, and constructionism. It sets these theories in the context of the big three orthodoxies, and makes the connection between these and the frameworks used to describe and explain learning. It clarifies the language and terminology we use when discussing the processes of learning and classroom teaching. There are three major orthodoxies of learning: constructivism, cognitivism, and behaviorism. Constructivism is concerned with what we understand and know. Cognitivism considers how we understand and know. Behaviorism is concerned with the changes that occur through learning. Within the fields of these three orthodoxies are a number of theories about the nature of learning. The most significant is based on constructivism. It is social constructivism. The other learning theories and frameworks for learning we will consider in this module are personal construct theory, connectivism, multiple intelligences, Kolb's learning cycle, social conditioning, and constructionism. A traditional view of intelligence is the idea that a human is born with an intelligence, sometimes known as G for general intelligence. This is often recorded as IQ, or intelligence quotient. Howard Gardner's theory of multiple intelligences proposes that people are not born with all of the intelligence they will ever have. Further, Gardner introduced 8 different types of intelligence, consisting of logical or mathematical, linguistic, musical, spatial, bodily kinesthetic, naturalist, interpersonal, and intrapersonal. But this is not a definitive list. Gardner acknowledged that there were other cognitive-based intelligences, such as moral, spiritual, and existential. People with strong linguistic intelligence can more readily analyze verbal information and be creative with oral and written language, such as making presentations, writing teaching materials, or explaining through words. Those with logical or mathematical intelligence have a higher capacity to analyze problems logically, carry out mathematical operations, and investigate issues systematically. This is an important aspect of our work in teaching with and about technology, and how we are developing our learners' capacities in computational thinking, as cited in the computing curriculum. There are 5 facets to computational thinking, as described by Computing at School in the UK. These are algorithmic thinking, decomposition, generalization, abstraction, and evaluation. Computational thinking is one of the current tenets of the national curriculum for computing. Algorithmic thinking is a way of getting to a solution through a clear definition of the steps. Some problems are one-off. They are solved, solutions are applied, and the next one is tackled. Algorithmic thinking needs to be applied when similar problems have to be solved over and over again. They do not have to be thought through anew every time. An example of this is an algorithm for doing multiplication or division at school. If simple rules are followed precisely by a computer or a person, the solution to any multiplication can be found. Once the algorithm is remembered, it doesn't have to be worked out from scratch for every new problem. Algorithmic thinking is the ability to think in terms of sequences and rules as a way of solving problems or understanding situations. It is a core skill that learners develop when they learn to write their own computer programs. To find out more about computational thinking, see the links in the course resources. Spatial intelligence features the potential to recognize and manipulate the patterns of physical and virtual space. Computer-based games require a high level of spatial awareness to navigate the various levels and structures. Second Life and other virtual environments require good spatial memory, and to some degree, so does the navigation around virtual learning environments. Bodily or kinesthetic intelligence is the potential to use the body or parts of the body, like the hand or the mouth, to solve problems or to make products. It is the awareness and interconnection between the learner and the physical world. Designing a new piece of origami would require a high level of kinesthetic intelligence. A person's social awareness is a reflection of their interpersonal intelligence. It is their capacity to understand the intentions, motivations, and desires of other people. This has connections with Bandura's social conditioning theory and the sociality corollary of Kelly's personal construct theory. Mindfulness is an intrapersonal intelligence. It enables an individual to recognize and understand his or her own moods, desires, motivations, and intentions. This is not a definitive list, and it is worth considering whether, with the pervasive use of technology in lives and learning, new intelligences will be recognized. Modes of learning are changing. The location of learning is changing. The formality of learning experience is changing. Some will claim that the actuality of learning, the cognitive processes, are changing. Prensky talks of digital natives and digital immigrants, and how in the formative years of a digital native, their thought processes developed differently. They think differently from the older generation of digital immigrants who have had to accommodate the new technologies in their way of thinking. Many of our learners will move into a variety of different, possibly unrelated fields of endeavour over the course of their lifetime. Everyone will have the opportunity to learn by different means. The theory of connectivism develops our understanding of learning as a dynamic multimedia experience with the learner in clear control. Constructionism provides an explanation or rationale for the value of learning in a technological environment, the value of exploring and making. Many cognitive theories reflect a cyclic structure of learning, for example, Kolb's experiential theory. This module has introduced you to just a few of the ways in which we understand the learning process. In the next module, we will be looking into some of the wide range of teaching approaches derived from these theories, or arising from classroom practice and rationalized by these theories.
To learn more, head over to edX.org and search for project-based learning and enrol for free.